Hello and welcome back to IT 1200 Introduction to Software Quality Assurance with Maureen Flannery. Again, the required textbook for this class is Foundations of Software Testing ISTQB Certification, 4th edition through Cengage Publishing. And before I start the lecture, I would like to remind you that prior to watching each lecture, I would like for you to read the chapter and take notes as you see fit. Chapter 2, 2.1. Software Development Life Cycle Models. Characteristics of quality testing for every life cycle model include 1. For every development activity, there is a corresponding test activity. This means that every time you work on a project or a feature, there is always a corresponding test to go with it. 2. For every test level, there is a test objective that is specific to that level. For example, there are different levels of regression testing, and within each one, there's an objective that should be verified. 3. Analysis and design of tests for each level should begin during their corresponding development activity. This means that testing should not wait until the end of a project or cycle. Testing should always start as soon as possible. And 4. Testers should help to define and refine the requirements and design. Often, businesses will design websites that have unrealistic goals. Then, testers have to report that the goals are not all possible. It is best practice for the business to let the testers determine this before any code is unnecessarily developed for the site. Sequential development models. 2 models are the V model and the waterfall model. There are more, but this chapter focuses on these 2. Conceptually, these models happen in a prescribed order. The design has a linear flow and refine the requirements over time. The following phases start if and only if the first phase is totally complete. Notice that I put in parentheses on that second last note, if and only if. That is often abbreviated to capital IFF. That's a term that you will see sometimes in shorthand for requirements, and I just want you to be aware of it in the future. Waterfall timeline model. The waterfall timeline model is a design that flows through each phase sequentially. Since testing is done near the end of the model or the cycle, the defects are found just before the implementation date. This makes the fix or the patch more expensive and time-consuming to install. It is very difficult to force anything up a waterfall, so that's a good way to remember that these fixes do not go up the waterfall model. V models. V model is an updated version of the waterfall model. It starts with testing as soon as possible, and it has 4 levels. These levels are component testing, integration testing, system testing, and acceptance testing. In component testing, the testers search for defects and verify functionality of software. In integration testing, testers investigate the interface between components. In systems testing, the testers look at the whole system and project scope. This is meant to be a verification of the actual system against the specific requirements. In acceptance testing, testers validate user needs and requirements. It is meant to help testers decide whether or not to accept the system. There are types that you will find in an order. There are times that you will find an error on a test, but you will have to find whether or not this is acceptable. I gave an example of an acceptable error last week with the motorized sailboat watercraft insurance policy. Iterative and incremental development models. Instead of one large timeline that goes start to finish like the waterfall or the V model, there is a different type of model. It has many small, isolated cycles for the overall project. It works to incrementally complete one piece of the project at a time. It is iterative because it is a continuous system. The system allows a business to see and refine the project as it grows. So In this slide, you can see the difference between the definition of incremental and iterative. Incremental is a little bit more each time, and iterative is a little bit more detailed each time. The iterative and incremental development models are meant to adapt to change constantly. Testing in incremental and iterative development. Common problems with the incremental and iterative development models include A. There is a constant need for more regression testing. B. There are defects that exist outside the scope of the iteration. And C. Less thorough testing is conducted in this speedy cycle. Automated tests are best suited here because manual tests don't pick up as many errors. 4 examples of incremental and iterative testing are the Rational Unified Process, RUP, Scrum, Kanban, and Spiral. RUP, the Rational Unified Process. The risk is the primary driver in this model. Quality is continuously evaluated. The phases are usually split into months instead of days or weeks, and are usually based on groups of features. The time frame is the most significant between RUP and the other models. RUP has much bigger cycles, which are composed of 4 steps. First, there is the inception, which is the initial idea and planning with stakeholders. Second, there is the elaboration, which is the detailed investigation of resources and architecture costs. Third, there is the construction of the software product and testing. Fourth, there is the transition, which is when the product goes to the stakeholder or client for modifications or for feedback. The stakeholder or client usually makes the final decision of whether or not to release a product to the public. Scrum. The term Scrum is a rugby term. In a Scrum model, the team meets daily for 5 to 15 minutes. It is an incremental and iterative development model that is good for team collaboration. Scrum recognizes change as constant and adjusts priorities as needed. It has short cycles called sprints that are days, but also can be as long as months. The teams are small, usually 3 to 9 people, and the team members all have cross-functionality on a project. Each sprint duration is time-boxed, and the tasks within the sprint are delegated at the beginning of the sprint based on the priority and the time needed. Kanban. Kanban started at Toyota as a way to visualize the work and workflow on a board. It uses columns as swim lanes and moves tasks across the board like an assembly line. The principal idea is to limit the work in progress so the workers can concentrate on one thing at a time. The model is more lean and efficient than other models. Kanban has a strong focus on user needs. So if you look at the picture here, you can see that they're moving the tasks from one side to the other. At my work, several teams do Scrum meetings, and they have a Kanban board. A business can utilize hybrids of these concepts. A Kanban model is especially nice for visibility, particularly on a very large project where one team may need to be able to interact with another team, like a testing team interacting with a development team. Spiral or prototyping. The software development lifecycle model of spiral or prototyping is risk-driven. It is favored for large, expensive, and complicated projects. The prototypes are created as a way to address the risks. Then the model used for these 4 steps: determine objectives for each iteration, identify risk and alternatives, develop a test or test suite, and plan next iteration. It's basically like you're doing the same thing over and over in this model, but the benefit is that you're getting better every single time. This is similar to a person who plays a sport. You practice, 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 and eventually it makes perfect. So every single time you run an iteration, the software becomes better. Agile development. Agile development model is a group of software development methodologies that use incremental and iterative development models. Here, the requirements and solutions evolve over time of a project. Agile development uses Scrum in small teams. It focuses on the process and documentation, which is a helpful practice for preventing future problems with the next project. Agile sometimes uses XP, which is extreme programming. This is basically when a group of developers get together and program until they cannot program anymore. Agile development has the manifesto that includes the concepts that individuals and interactions are more important than processes and tools. So basically, you and your colleagues and how you get along are more important than making the project work. Working software is more important than comprehensive documentation. So a lot of times we'll have documentation that is insufficient, but the priority of proper paperwork is less important than actually having software that is working. Customer collaboration is more important than contract negotiation, which means that the customer should give input to create the ideal product, even if the work is not in the contract. Responding to change is more important than following plans, which is something that you should already know at this point in your life, and you should probably live your whole life that way. Note, in this class, a customer or client is a hypothetical term for the business that has requested the creation of the software. Some advantages of the agile development cycle include the following. 1, it has a focus on quality. 2, it is test-driven with tests beginning early. 3, it provides access to business analysts or customers to ask questions. 4, it emphasizes teamwork where everybody works on the project. And 5, it has a simple design. Note, I work in an agile environment and the emphasis on teamwork is real. It's not just a generic buzzword for a business. Agile development has some disadvantages as well. These disadvantages include 1, requirements are not well documented because they are less formal and they are subject to change. 2, there is a misperception that testers are not needed, which goes back to the absence of error myth again. 3, the roles of the testers can be different and adjust as needed, which requires flexible personalities. And 4, there is less testing per iteration because there is less time with more coverage to test, and each cycle with a constant time pressure. And 5, regression testing becomes more important because there is a constant addition of code to the existing system. Automated testing works best in this aspect, but it is very expensive. Here's a quick example of the absence of error myth that I hope will stick in your memory. I'm an automated tester at my job, where we go through tests every single day to create fake insurance policies. I was creating an insurance policy for a farm when the website asked for the number of horses on the farm. In the website, I entered 1.5 into the system. Because the site was only equipped to handle integers as input, that 1.5 that I had entered caused an incomprehensible error message. Following proper protocol, I sent a report to the developer to report this error. The very irritated developer asked when a portion of an animal could live on a farm. Basically, he was suggesting that I was ridiculous for entering this bad data. I responded with the attached picture in this slide, which is a picture of Dwight Schrute from The Office. My point here is that the system expected a number as the input and it worked, which is fine. But the system should be able to accept bad data and return an appropriate error message. Just because the system was working for the developer does not mean that the system is entirely working properly. 2.1.2 Software Development Lifecycle Model in Context. When creating a software, a project should have the appropriate development model, which should be based on 1, the project goal, 2, the type of product or software being developed, 3, the business priorities, which should be considered the time to market, and 4, the product and product risks, such as the product for entertainment or is the product for a medical device. Or COTS is an acronym for commercial off-the-shelf. It is a term for pre-made, semi-customizable software instead of a software that is created entirely for a specific client. COTS has some modifications created for the specific client tested in after integration, and then has some product support. IoT is an acronym for the Internet of Things. It is a term for a system where real-life testing is needed to see if everything works together correctly. This checks for usability in real-life situations. A real-world example of this is the internet in your home. Can you stream a movie on your Roku while I go on Facebook with my phone? Now let's take a quick break.